Yes, all right. Thanks, everyone, and I hope you're all enjoying DevSecCon 24 today. And I'll be talking about exploiting and fixing vulnerabilities, a gamified approach. So my idea is really I want to address developers or those who lead developer teams and develop software applications as part of a product or a program within the company. A bit about myself. So I have a background in software engineering in different roles as an entrepreneur, co-founder, CTO for 20 years. Always been in product business, and then at some point 5 years ago, I moved into security with a focus on first identity access management, and then AppSec and DevSecOps now at Sneak. And I'm currently leading the solutions engineering operations for the DACH region at Sneak. So basically, I come from this developer background, basically, and this is why I can feel how developers actually think about security sometimes, or when I remember that when I was running projects with customers and mixed teams, we had maybe 14 full-time people in the team, maybe three full-time QA people, but there was hardly any security person. So now these days it has gotten better, but still security isn't always part of the DevOps methodology of process yet. And the idea is, or I want to discuss how we can improve this bit. So first of all, a bit of the explanation of the problem space we're dealing with. So when we look at how modern software applications are now developed these days, I like to use this iceberg slide to explain the software supply chain and the risk that comes with it. So on the left-hand side, you can see there I have my, this is my code base. The whole iceberg is my code base. I have my proprietary code, the code I'm writing, and it makes maybe 10 to 20% of the whole code base. Now, this is something where I can use a static analyzer running on this code base, and then I find some maybe vulnerabilities or security holes in this code base. Then we have open source code because we are using a lot of open source libraries on our application level because we don't want to reinvent the wheel. And these open source libraries or the code of it makes 80 to 90% of the whole code base. And also we do with all the dependencies we use in our product, there comes a lot of indirect or transient dependencies. So in fact, 80% of all the dependencies are actually indirect dependencies. And with these indirect dependencies, we have a lot of course, vulnerabilities somewhere hidden on a second, third, or fourth level of the so-called dependency tree. Then we have containers. So if I use mostly, let's say, Linux-based container images, I have the same problem there. They consist of a lot of open source libraries, not often on the operating system level, or the open source libraries that go into the package registry of the respective image. They also can be full of vulnerabilities I want to be aware of. And then we have, let's say, if we go to the cloud, run our applications in a containerized way in our Kubernetes cluster, we might defining the infrastructure as code. So we might be using Kubernetes deployment files or Terraform or CloudFormation, whatever our cloud provider is. And the problem is that a lot of the default configurations aren't perfect in the sense that they're not most secure. I have to do some proper adjustments to it to actually make my infrastructure and environment secure. And this is also the main problem that the NSA points out. The number one problem of cloud vulnerabilities are misconfigurations. And because container images or containers, they get spun up very fast, they get torn down again very fast. It's really the challenge to keep up with the pace we are developing, but also the pace we are deploying to the cloud. Now, the only way to address security is actually to empower developers. This is because obviously I'm working at Sneak, so this is our philosophy as a vendor coming from the security space. We want to empower developers. Reason for this is because we have this ratio of, let's say, in a modern technology company, we have 100 developers. For these 100 developers, we might have only 10 ops people in place. And then for these 10 ops people, we might have one security person in place. Now, this obviously doesn't scale because, let's say, if we release on a daily basis or we push out a release multiple times during the day, there's just no way that this one single security person can do reviews properly for all the releases we want to push. So we need still the security people and the ops people to provide some guardrails, maybe some security policies, but in the end, we want the same way cloud serves as a self-service approach for the infra. We want developers also to use a self-service approach for security, where the tooling is in the hands of the developers, but it's guided by the security team. So this is a quote here from Gene Kim. He's the author of the book, The Phoenix Project, which I can recommend to read. He's also the co-author of the DevOps Handbook. And this ratio 100 to 10 to 1 actually comes from one of his articles on dzone. Now, let's say if we say we want to shift left, we want to give the developer control of the security tooling, we want to enable them. Of course, let's say they could use Sneak or any. It doesn't really matter which tool it is. It can also be any other tool. Important thing here is we want to give tooling and integrate it in a way that is easy to implement for developers. So developers shouldn't learn a new tool. In a perfect scenario, this would integrate into the existing environment. This means the local IDE. So for example, if you look on the left here, where it says code, this is where I have my IDE, I write my own local code. And I can nicely scan for security issues then in my IDE or maybe in my local terminal, even before I commit anything to my Git repo. Now, further down then, if I do commit to the Git repo, let's say GitHub, GitLab, or whatever it is, I can also nicely integrate any tooling there. I can, let's say I have pushed my project. I don't even touch my code base anymore because it's released, but then new issues are being found. This is a nice way to regularly, let's say on a daily or weekly basis, recheck my repository or my code for any new issues that are being found through research, for example. Just remember when Log4j came out, it was in a very old library, but it took a while to actually be discovered. And then we can use security tooling as well in the CI/CD pipeline, whereas actually, let's say a developer didn't fully cover everything in the IDE or on the very left, we can use any tooling in the CI pipeline where we also can act as a security gate. And we can say, okay, I'm fine with any low severe issues, but if there's anything that is high, severe, or critical, I want to break the build pipeline and it shouldn't go into staging or production and so on. And then once applications are running in production in our cluster or elsewhere, we also, of course, want to be aware of what's actually running there and prioritize, let's say, the container images that are actually in production to be scanned even when they're already rolled out and executed in the production environment. Now, tooling is one thing, right? Let's say we have these nice, whatever tool you're using in place. It's just one thing or one part of the whole picture, right? It's just a tool in the end. So, but how can we make developers aware of security or make this application security topic a bit more tangible, right? Because just because I have installed or rolled out the IDE plugin that does security testing doesn't mean developers are using it, right? Or maybe you have a tool in the local terminal, but no developer is actually focusing on it because, to be honest, developers have a goal. They want to push business logic in their application. They want to push new features. This is what, they're paid to do. And like technical documentation or security is just part of the whole development or software package, but it's not the primary focus. How can we make this topic of application security a bit more tangible, that developers actually understand why it matters that you have a potential SQL injection vulnerability in your code or remote code execution and so on? And the best thing to do is, in my opinion, to actually let developers switch roles and go into one of a offensive security person. Now, this is where I think capture the flags session come into play and do a very good job. And I want to explain for those who don't know what capture the flag sessions are. It's a gamified approach where you or the developers, they go into the role of pen tester or offensive security person, and they are exploiting vulnerabilities in certain environments. And these environments, which I will show you in a bit, they run intentional vulnerable applications in VMs, and you can then go ahead. It's like an escape room or an exit game. You want to find this flag inside this virtual machine. And this flag is actually, for example, a text file. This text file has a string, and this is your goal. You have to find this string hidden in some text file. That is the whole idea. Now, I like to run this kind of session that I'm doing today actually interactively with customers very often, but because we have limited time today, I just give you a walkthrough how I would usually do it and like to play around with developers with this kind of approach. So there's one very nice CTF or capture the flag platform out there on the web. It's Hack the Box. And I have no commercial affiliations with Hack the Box. It's just because I'm a regular user. I'm actually a customer of theirs. I just like this platform because in my opinion, it's one of the best ones out there, well structured. And the idea is really, they have these, what you can see here on the screen, challenges. And they have also machines. Now, machines and challenges differ in a bit. The challenges are a bit simpler. Their ideas is they give you a web application. This web application, once you start it, it will give you an IP address and a port number, and then you open it in a browser, and it will show you an application. And your goal is then try to hack this application, try to find this flag, what I mentioned. And the flag obviously is somewhere on the server side, which you usually don't have access to. But because there are some vulnerabilities, you can, of course, find your way through it. That's the idea. Now, there are a bit more complex machines where the idea is that you would first try to find this flag on a regular user level. And then the next step would be you want to do privilege escalation and actually get the second flag in these machines, which is then of the root user. And for all of these flags, you get some points, and with these points, you can get a nice score, go up in the leaderboard. And if you're playing in a team, of course, the one with more points wins in the end. Now, in this case, I want to show you one example. This challenge is called Blinker Fluids. They give you this IP address with the port, and they give you also, in this case now, some files. So they actually give us the source files of this particular application. What I can do now is, first of all, let's open the web application. And this is what we see. Very simple. It's just a web application running in the browser. Nothing spectacular. It's just, obviously, we can see their invoice list, where it's a list of PDFs of invoices. Obviously, there's a button, create new invoice. Now, if I wouldn't do this walkthrough, I would give you the challenge to try to see what you can do, how you would find your way into this application. This can be through port scanning. This can be through looking at the source code. Maybe there's some hint in a JavaScript file somewhere, or somebody left a comment with some, maybe a password or something that shouldn't be there. Maybe I can look in my robots.txt file and so on. Now, in this example here, let's walk a bit further. Once I click this button to create a new invoice, I get this form. So obviously, we get the idea of this application. Very simple. I can write an invoice in Markdown language, which is a common format, and then I can save it as a PDF file. This is the whole purpose of this very simple demo application. Now, there's nothing wrong with it. This works fine. And obviously, once I do it, I hit the save button. I get this nice invoice that I previously wrote in Markdown. Now, let's go into the role of this pen tester or the one attacking the application. Now, once I download the files that Hack the Box provided me, I get this list of the zip file of all my application files. So in here, you can see I have a Docker file. I have some, obviously, it seems to be a Node.js application. We can see here I have a package JSON and a package log.json. And now this is, of course, a very good first starting point to analyze and see if there's any vulnerability hidden in this code base or maybe in the dependencies that I'm using. So I will be analyzing, in this case now, the package JSON and the package log.json, which are showing my dependencies. And this will be then in my local terminal. Once I list my directory, I get the same structure here. I have my Docker file. In this, you can see the challenge folder there. There is the application sitting there. And let's say I'm actually building this Docker image. This is what this screenshot is showing. Now, in my case, I want to see if there's any vulnerability in there that I could potentially exploit. So I run a container scan or a container image scan. I use Sneak, but of course, any other tool will do as well. But since I'm most familiar with Sneak, I use this one now, Sneak container test, and then I give the image name and I say, only show me the high severe issues or critical ones. So once I run this container image scan, what I'm getting is a list of issues. First of all, I get some issues on the container image level, on the OS level, where the vulnerabilities are coming from packages in my libraries that are registered in the package registry. Let's say if this is a Debian image, it would be the dpack. And then also I get some base image recommendations where I can acquire to, but this is now, of course, if I'm in the role of the developer and the defensive side. But for now, I want to attack, so I care more about offensive and attacking and getting in. So let's go a bit further. Since we have the application packed into this container image, and it's a Node.js application, we have the package JSON sitting there somewhere inside this container image. The scan will also give me information about issues of this particular application. So in this case here, and I hope you can see it, it gives me a critical severity, and it's a remote code execution. And it tells me here it's inside the MD to PDF library in a particular version 4.10. So MD to PDF stands for Markdown to PDF. Obviously, this is the converter library we use here for conversion. And it also gives me a link to what's called the vulnerability database of Sneak. So this obviously seems like a very good entry point we want to analyze a bit further. Now, if I would be doing the same and adding this into the Sneak web UI, I can get the same information there where I get a nice image, the container image scan with some results. Also, you can see here the package JSON again, where we again have this critical severity pointed out. What's happening in the background, basically, with this kind of analysis is that tools like Sneak, they build a dependency tree. They build a tree from the first level dependencies, the direct dependencies, but also then include all the indirect dependencies to the second, third, and fourth level, and then also show the vulnerabilities in all these levels. So obviously, the critical one that we see here, MD to PDF, this is what we want to look into. Once I click the link that leads me to this vulnerability database, we will see this more detailed information about this particular vulnerability. The remote code execution, we can see there, it has a CVE number at the top, which is the ID of this particular vulnerability. But also the important bit I want to showcase here, for an offensive person, let's say I'm just a script kiddie, right? I have no idea what I'm doing, but I just want to exploit the application. It's so simple to exploit this. This is my point here, right? We get everything, including an exploit POC. So you can see here that POC that shows the sample code how to exploit the issue, but we also can click a bit further to the actual original GitHub issue, the issue tracker. Once I do this, we can get a nice code snippet You can see here it's surrounded by JavaScript, and then inside it has some CSS styling, which is usually just meant to be for styling the layout of a page, or in this case, the PDF. But we can see here also that inside this styling, there has been injected some Node.js commands, require file system, and then read the directory from the root. And this is the actual vulnerability, because this line of code of Node.js code is actually being evaluated on the server, which shouldn't happen because it's just any random user input that isn't being sanitized. This is the actual vulnerability. Now, if I have no idea what I'm doing, but I'm just copy pasting this snippet, I can do this, and I can actually exploit the vulnerability. So I take this, copy paste this, put this into this web application that I showed you before into the editor. That's all I do. Put this in here, and once I hit the save button, we get the PDF generated, and you can see here it shows me the directory structure of the root level. This is the exploit. Now this is only reading the directory structure. Of course, we can now see the flag.txt. This is now the challenge. We want to get the content of this flag.txt. Now I can do a bit of adjustment with this command. I can change the command there to require file system, and then read me the file synchronously from the flag.txt content file. And when I do this and generate the PDF again, I would actually get the PDF, click on it, and get the flag. This is the challenge. I take the flag. I have mastered this challenge. You can see here how easy it is for anybody, just any script kiddie, to just exploit this if you're not fixing the issues. Now, this was the offensive part, and of course, in a proper session that is interactive with customers that I like to run, of course, I wouldn't walk them through it all the way, but of course, the developers have to play around a bit and see if they can find their way in. Now, from the developer's perspective, from the defensive side of things, of course, I want to protect my application against these kind of attacks. So I can use tools like Sneak or any other tools that is out there that's doing static analysis and software composition analysis, or also called SCA. And in this example here now, I show you our IDE plugin, where if you do a scan on your application, you can see that we recommend, okay, I probably should upgrade my MD to PDF library to a higher version. And now, let's say, because I have gone through this capture the flag, I can now better understand why it's important, why it really matters, and if I would play a bit more CTFs and do some proper privilege escalations and maybe escape some Docker containers and do a bit more, I have a better understanding of why these things are actually important, and it's not just a term thrown at me like, hey, care about OWASP top 10, right? This is the idea. So, and from experience, I can say that when I run these sessions at customers, it's very engaging. I mean, developers really like this kind of, let's say, entertaining or gamified approach. It really resonates very well. Of course, you can want to fix the issue, you upgrade to a higher version, then you understand why you're doing it. And this screenshot now shows you the upgrade path and how you can fix it by simply opening a pull request, and you have the issue resolved. Looking at the time here, I'm closing soon. Just want to show you that if you want to go with this gamified approach, you can play it with your developer team in a team, really, like in a gamified approach where you have a leaderboard. Like here, for example, I have a Sneak team inside of, let's say, Hacklebox. We have different points. For every flag you're capturing, you get some points, and you can, maybe offer some swag or something to win in the end. That's it. I think we're good in time. I want to make one announcement that today, actually, if you like this idea of gamification and CTF, we do have, thanks for showing this, we do have something going on tomorrow. It's a virtual Capture the Flag session with our partner, Global Debts. You can just sign up for free online. And that's it from my side. Thank you very much.